Dear students, in the previous class we have been studying the nth term of the arithmetic progression is Tn equal to a plus n minus 1 into d. There we can find out the number of elements as well as the nth element of that given series by using this formula. And now we are going to be studying the new one concept in the arithmetic progression is the sum of first n elements. Sum of first n elements of an arithmetic progression. The sum of the first n elements of the arithmetic progression, that we have the formula is that is sum of means that is Sn is equal to n by 2 to a plus n minus 1 into d, or else we can write this one as the bar Sn is equal to, I can split this one as n by 2 to a as an a plus n minus 1 into d. So now I will substitute that a plus n minus 1 into d, that is nothing but the nth element, or else we can say that is the last element of that given series as Sn is equal to n by 2 a plus n. So these are the two formulas. Both are having the same similarity, that we can either write the sum of the first n elements as the Sn is equal to n by 2 to a plus n minus 1 into d, or else that is Sn is equal to n by 2, that is a plus n, where n is one last element, or else we can say it as the nth element of that given series. Okay, so depending on this concept, now we are going to solve some basic examples. Okay, so one of the first example is find the sum of 30 elements. The first one example, find the sum of 30 elements. Find the sum of 30 elements of an AP that is 1, 3, 5, 7 to 30 elements. We have to find out the sum of the 30 elements. So if we keep on writing this series up to the 30 elements and we have to add all those elements, so it will take some time if we are doing a simple method like 1 plus 3 plus 5 plus 7 plus 9 plus up to the 30 elements, and we have to add all those elements. So it will take some time, but by using the sum of the first 10 elements of the series, we can find out within 2 or 3 steps. We have to find out sum of the 30 elements. It means how many number of elements we are going to be add, that is 30, and here the first element is 1, that is 1, and the difference, common difference is what, that is 5 minus 3, that is 2, or 3 minus 1, that is 2. The common difference should be the same. Therefore the sum of 30 elements means that is S30 is equal to, that is n by 2, that is 2a plus n minus 1 into these, because I don't know what will be the last element. If I know the last element, then I can be substitute here it as the n by 2, that is a plus n directly. Okay, that is, this is 15, this is 2, plus this is 19 2s are, that is 38, because 30 minus 1, that is 29, I'm sorry, 29 2s are, that is 58. Okay, so that is 15 into 60, that is how much? 30, 60. So this is what the sum of the 30 elements. Okay, so the next one is having the next one example. the next one example. Evaluate 1 plus 3 plus, I'm sorry, 2 plus 5 plus 8, 2 plus 5 plus 8 plus up to 152. 152. So evaluate means what? We have to add 2 plus 5 plus 8 up to the 152. We have to add. So here first we have to find out that here we know that is the nth, that is the last element, even though we know the first element, but we don't know how many the elements here we are going to be add. So how many elements? First we have to find out how many elements we are going to add up to 152. That we can find out by that is Tn equal to a plus n minus 1 into d. So a is 2, common difference, that is 5 minus 2, that is 3, and Tn, that is n element is 152. That is Tn already we know, that is 152 equal to 2 plus n minus 1 into d is how much? That is 3. That is 152 minus 3, that is 150, that is 3n minus 3. Again 153 is equal to 3n, then n is equal to, that is 3 5s are, that is n is 51. So we have to add the 51 elements, that is nothing but S51 is equal to n by 2, 51 by 2, a plus n, that is 2 plus 152, that is 51 by 2, this is 154. So 2 1s are, 2 2s are, that is a 2 7s are, that is 51 into 27. The total, the sum of this one is 2 7s, I am sorry, not 27, 2 7s of 14, again 2 7, that is 77, I am sorry, that is 51 into 77, that is 3 9 2 7 is your answer. The sum of, that is 2 plus 5 plus 8 plus 11, because common difference is 3 plus 14 up to plus 152 is how much? That is 3n, 3 9 2 7. Okay, so this is also one of the simple example. The examples are very simple. In the sum of the first n elements of an AP. Okay, so the next one is, in an AP, if pth element is 1 by q, pth element is 1 divided by q, and qth element is 1 by 3, and qth element is 1 divided by p. Prove that the sum of first PQ, prove that sum of first PQ, prove that sum of first PQ element is 1 by 2, element is 1 by 2 PQ plus 1, 1 by 2 PQ plus 1, where P is not equal to Q, where P is not equal to Q. Okay, so in this example what we are given, the pth in an AP, the pth element, like nth element, we take the pth element, that is TP. TP is 1 by Q, and qth element that is TQ, and TQ is 1 by P. We have to prove that the sum of first PQ, that is SPQ, what we have to give is 1 by 2 PQ plus 1. We have to prove this one condition, that is sum of PQ. Okay, so now we have to expand this one, that is TP is equal to, that is A plus P minus 1 into D. Instead of n, we have been substituted as dp. This is, I will take it as the equation 1, and dq it as the what? That is A plus Q minus 1 into D So this is what the second one equation. So now what I will do, I will subtract the equation 1 in equation 2. Then I can get it as the either the common difference D or the first element as the A. Okay. Therefore, equation 1 minus of equation 2. So here, sorry, this one is what they have given, that is 1 by Q. This is first one equation, and second one equation, that is PQ. PQ, how much they have given? 1 divided by, this is second one. Okay. So therefore, the LHS term is going to be subtracted in LHS and RHS in RHS. Okay. The LHS is A plus P minus 1 into D minus, that is A plus Q minus 1 into D. And in the RHS, 1 by Q minus 1 by P. Okay. So multiply that minus inside the bracket, then A plus this is PD minus D minus A minus QD plus D is equal to by LCM, that is PQ is LCM, this is P minus Q. This is P minus Q. Okay. So here which terms are going to be subtract, that cancel, plus D plus D plus D minus D get cancelled, plus A minus A get cancelled. Here PD minus QD, if I take the D as the common, what remains, that is D into it. P minus Q equal to P minus Q divided by P. So this P minus Q get cancelled, then P is equal to 1 divided by P. So substitute this D in one of the equation, then what you get, the value of A. Then what you get, the value of A from equation 1. From equation 1, what we have, that is A plus P minus 1 into D is how much? That is 1 divided by PQ is equal to 1 divided by Q. Or else you can substitute in the equation 2 also. Okay. So now what I will do, I will take the LCM of this one. That is LCM is APQ. APQ. Or else I can take this one to the LHS, then also no problem. Or else I will do here only, that is A, then I will take this one to the 1 by Q minus P divided by PQ, then plus 1 divided by PQ. Just what I did, I multiply this PQ inside the bracket, that is P divided by PQ and 1 divided by PQ. Then P divided by PQ, if I take the RHS, then it is minus 1 minus P divided by PQ, then minus, if I take to the RHS, then it is 1 divided by PQ. Okay. So here the LCM is PQ, and here I am going to be multiply this one with the P. Then A is equal to LCM is PQ, and here it is PQ minus P, and here it is plus 1, and here it is plus 1. Okay. So here just I am going to be check this one. What we can be do? Or else here I can cancel this one. I am not seeing properly here. Here, so look here. This one of the P get cancelled. Then A is equal to 1 by Q minus 1 by Q plus 1 divided by Q. So plus 1 by Q minus 1 by Q get cancelled. Then A is equal to how much? That is PQ. Okay. 1 divided by PQ, because here one of the P get cancelled, what remains? 1 divided by. Therefore, yes, PQ, the sum of this PQ, then I can be substitute here it as the. Here I don't know what is the last element, so better I will take PQ divided by 2, n by 2, 2a, that is 2 divided by PQ. 2a means 1 divided by PQ, 2a plus n minus 1, that is n minus 1, that is PQ minus 1. N minus 1 into D is again 1 divided by P. Okay. So PQ divided by 2, if I take the LCM here, that is plus PQ, and sorry, 2 divided by PQ plus PQ by PQ minus 1 divided by PQ. So here this PQ by PQ get cancelled. 2 PQ minus 1 PQ is again PQ. That
divided by 2. 2pq plus pq is again 1 divided by pq plus 1. So multiply this inside the bracket, then what I will get? SPQ is equal to PQ by 2 multiply inside the bracket, then PQ divided by 2 PQ plus PQ divided by 2. So what I want to show that is 1 by 2 PQ plus 1, or else 1 by 2 I will better I will take the 1 by 2 and only PQ I will multiply inside the bracket. Only I will multiply that PQ inside the bracket. It means 1 by 2, that is PQ divided by PQ plus PQ. Then PQ get cancelled, that is 1 divided by 2, 1 plus of PQ. That is what you are, that 1 plus of PQ is nothing but that is PQ plus 1. So this is what the sum of the PQ element is, 1 divided by 2, 1 plus PQ. So this example is very simple. So again I am going to explain this one. This example is very simple. Okay. So now what I will do, here what they have said, in an AP the pth element is 1 by q and the qth element is 1 by p. Prove that the sum of first PQ is 1 by 2 PQ plus 1, where p is not equal to q. So here like that nth element like they have given, the nth means that pth element, that is tp is equal to 1 by q I consider, tq is 1 by p I consider. What we have to prove, that is sqp or spq is equal to 1 by 2 pq plus 1. So here I have been written in the formula, that is tp is equal to a plus p minus 1 into d is equal to 1 by q. This is first one. And tq is equal to, that is q a plus q minus 1 into d is equal to 1 by q. That is second equation. I subtract the equation 1 in equation 2. Then what I will get after subtracting, I get the common difference, that is d is equal to 1 divided by pq. Substitute this d is equal to 1 divided by pq in either equation 1 or in equation 2. Then you are going to get the value of a. So now what I get here, for the sum I need the number of elements they have given, the common difference as well as the first element. So I get the first element as well as the common difference, and I substitute in the, that is Sn is equal to 2a plus n minus 1 into d. So that n, instead of n I have to be substituted as the pq, n by 2, 2a means 1 divided by pq plus n is pq minus 1, that is d is 1 divided by p. First what I did, I multiply this pq inside the bracket, then I get this one term. Then 2pq divided by 2pq minus 1 pq is 1 pq, and here it is having, after cancelling, that I have the plus 1. Then I multiply the PQ inside the bracket. PQ inside the bracket, then what I get? The proof of this one condition. Okay, so this is nothing but that I have been shown. The sum of the PQ is, that is 1 divided by 2 PQ plus 1. So this is what the example we have been shown here. Okay, so this type of example is for the 3 marks, remember. Okay. So by pausing the video, you have to note down the notes, and along with that, you have to give the attendance without miss. Okay. If you have any queries, then you can ask me through the call. Okay. So the remaining examples will be continued in the next class.